solar wind. And so those push, and they have very low mass. So they push straight away from the sun. So if you connect a line down that ion trail, that's always going to be pointing directly at the sun.
Directly at the sun.
Yeah, we'll talk a little bit more about the direction of the tails, but in essence, that's all that a comet is. It's just this
So the anatomy is, there's a bit there that we can't see, which is called the nucleus. That's hidden by the really bright area that we can see, which is the coma. Or the comet's head. And then we've got sometimes one tail, but often two. And I think we're going to see in some of your superb images that you've taken over recent nights, we're going to see quite clearly, you know, that second tail. And I kind of always love that, just looking at an image of a comet, and when you see its iron tail, the colorful one, you always know where it is in relationship to the sun.
Exactly.
And you know, so how big then is the nucleus that's hidden behind that coma of gas and dust then, Mike?
Yeah, it's not big. It's only a few kilometers. You know, it's relatively small. It's something that, you know, is something we could hike across. I mean, if we were on the comet's nucleus, we could probably walk across it in a day if we could, you know, imagine such a thing. It's relatively small, and yet this thing is pumping a huge amount. If you can, I didn't write down the numbers, but there's an enormous amount of material that's being ejected every second, and it's kind of mind-boggling when you think about it. But it's not that big. And then, but the tail, on the other hand, is a whole different thing.
But even the coma is as well. I mean, that nucleus that we're talking about, you know, I don't think there are many comets that get above kind of 10 miles, you know, 15 kilometers in diameter. We believe that the majority of the nucleus, the nuclei, are about 3 miles, about 5 kilometers across. But of course, we can't see them because they're usually shrouded by the coma, and the coma can sometimes be thousands of miles in diameter.
Tens of thousands.
Tens of thousands. Wow. Yeah. You know, so we've got this, you know, that real core of the comet. We never really see it, you know, and that's one of the things to me that always makes comets so mysterious. But Mike, have you got, let's just have a quick look, actually, because we did say where this is. Now, we'll go over to Russ in a minute, because he can explain the kind of orbit that we're seeing on this. And there's the solar system. We can see the sun's in the middle. We've got a nice round orbit of Mercury and Venus. And there we can see Earth. And then we're out to Mars. And here we can see the orbit, this parabolic orbit, I believe, that Comet Neowise is taking. Now, it's been over here. It was at perihelion, which was closest to the sun a short while ago. This is where it is exactly now as we speak. And I was saying that in a few days' time, it's going to be closest to Earth. And you can see that how far it's going to be traveling, you know, from here over to here to get close to Earth. Now, this is three-dimensional, of course. So if we kind of look at this, it's
nice.
But we can see here that, you know, it's going to have this close approach. To Earth and close. I mean, it's so distant, but it's this combination of the comet being really quite close to us. It's just had its close passage to the sun, so all of that energy that you were talking about, Mike, that excites all of those volatile substances on it, you know, creating those lovely tails and stuff like that. It's that lovely combination, very active, nice and close to us, but it's not that easy still to see. And we're going to take people through some of this a little bit later.
Excellent.
We've got some sky charts for you, and Mike in a little while is going to explain how you can see this, because he's been the absolute expert at spotting this. But Russ, I think we should hop over to you, because we said at the beginning that this comet is called C2020 F3 Neowise. I mentioned another comet, Comet 1P Halley. Now, those are two very, very different names, and it's because they're very different types of object, aren't they? Can you explain this difference between comets that maybe we see more than once? And comets that we only ever see once?
Yeah. So, yeah, I'd love to talk about that. What I'm gonna, go back a little bit to what Mike said earlier when he mentioned that this particular comet, about 6,800 years, so 6,800 years is its period. That's its orbit around the sun. And so, what we've done is we look at these different comets and we put them into categories, and we look at how long it takes for them to orbit. And that's really how we organize things, that we categorize them. So this particular comet, it fits into a category of something called long period comets. And I want to talk a little bit about those, but I'm going to do a quick screen share if that's okay, Paul.
Yes,
right?
Yeah.
Okay.
Yeah.
So I'm going to share this because...
by the way, Russ, sorry, I forgot to ask, but when you've done this a little bit, could you give us a bit of an update on what's happening in the world of SLU education? Because I know that members, when they're in the star parties, always like to hear kind of what's going on, some new schools, colleges, stuff joining SLU. So maybe you could give us a bit of an update later as well. So anyway, sorry.
I definitely will. No, I'd love to. I'll definitely talk your ear off about what's going on in SLU EDU land for sure. Paul, I'm going to need you to stop your screen share so I can share mine.
That's done.
But I want to talk real quickly. I'm going to do a quick screen share here. Let's pull this up. And I want to talk a little bit about the reservoirs for comets. And Mike mentioned these a little bit ago. So something called the Kuiper Belt and the Oort cloud. So I want to talk just quickly about those, because those play into when we're thinking about comets and trying to define them. So, when you think about the formation of our solar system, we have, and this image right here shows it really nicely. We have this plane where major objects fit into this plane of our solar system. And this, as our solar system was forming, flattening out, kind of like a record on a record, those are coming back into style. So kind of like a record, we have the major objects in a nice plane here. But there was also a lot of material that was basically kicked out of our solar system. This was cold material, ices, things called volatiles. These are things that would vaporize in heat. The things that Mike was talking about earlier when he was talking about the comet sort of melting as it gets closer to the sun. So the Oort cloud is this sphere of material that's out, and it's it's about a light year away. It's really far away, or it varies. I mean, it covers up to about a light year away. 100,000 AU. I think a light year is about 60,000 AU. Now, an AU is an astronomical unit. It's a way that we measure distances in our solar system. It's based on our distance from the sun. So we have this cloud of material that's really far out, and it's a sphere because things got kicked out randomly. And then we have this other reservoir for comets called the Kuiper Belt, and it's in that plane of our solar system. So out beyond the planets, we have this Kuiper belt. This, again, icy material, but out beyond the planets. And these are our two reservoirs for our comets that we see. And so you can see in this image that I'm sharing with you guys, I'm going to line it up so that the plane is really right online. You can see the plane of our solar system right there. Those are the planetary, that's where all the planets are orbiting in this plane. And then you can see that this comet that we're looking at now, this one that's visible, is called, is a long period comet. And you can see its orbit is not in that plane. So, you know, this is part of the evidence. We've never observed the Oort cloud. We haven't observed it directly, but part of the evidence for its existence are these comets that come in not on the plane of our solar system. So they come in on a different inclination, and they're not in this plane. So this is part of the evidence for the existence of the Oort cloud.
Okay.
And these are these long period comets that are coming in. You know, we also, you mentioned Halley, which, you know, when I was a kid, Halley's comet was visiting Earth again. It's a comet that visits, you know, every 76 years. That's what that P that you were talking about stands for. It's a short
Periodic, right?
period comet. You know, and there's actually two categories of short period comets. So a Halley type comet has an orbit anywhere from 20 to 200 years. These are comets that, you know, will orbit the sun anywhere from 20 to 200 years. And then there's another category of comets. These are called the Jupiter family comets. And these are under 20 years in their orbital period. So these are ones that, you know, are orbiting very either inside of the orbit of Jupiter or just outside of the orbit of Jupiter. A lot of those comets, since they're close to the sun, have lost their ices or are in the process of losing their ices or lose their ices very quickly. You know, we sort of see this continuum of asteroid to comet, but, you know, after a comet loses all of its ices, it's hard to tell it's apart from an asteroid. So we have these, you know, short period comets, like you mentioned. Halley is, you know, a famous comet because it was the first one that its return was predicted mathematically.
Yeah, that's and the tragedy of that story is that Halley didn't live long enough to see his predicted comet return. I always think that's one of the tragic stories in astronomy. He was the first person to predict the return of a comet, but then he died. And I think it was only a couple of years after he died that it miraculously reappeared.
Yeah, I mean, poor guy. Halley, actually, that happened to him again, actually. He, you know, mathematically helped us figure out how to determine how far we were from Venus based on its transit across the sun. You know, he mathematically calculated that out, but didn't live to see the actual transit of Venus because they're so infrequent. Oh. So yeah, Halley did a lot of work that he didn't get to see come to fruition. But yeah, so, you know, when we're looking at a comet like Neowise, the one that we're looking at here, based on its orbit, it's a comet that came out of the Oort cloud. So these long period comets came out of the Oort cloud. You know, the shorter period comets, they have different origins. Some of them are probably out of the Oort cloud. We can look at their orbit and see the inclination of their orbit will provide us with some clues as to where they came from. So, you know, when we look at, you mentioned Hale-Bopp earlier, this is another long period. Here's Halley's comet. You know, it's still inclined to the plane of the solar system. So, you know, perhaps came out of the Oort cloud and then it was perturbed further as it came into the solar system. But these Jupiter family comets, here's one of those. Here's a Jupiter family comet. You can see it's almost in line with the plane of the solar system. So these are thought to come from the Kuiper belt. you know, comet like Halley, maybe Comet Belt, maybe the Kuiper Belt, maybe Oort cloud based on its inclination, thinking it's probably the Oort cloud. But these longer period comets, these guys right here, Hale-Bopp and Neowise, these are certainly from the Oort cloud based on their inclination to the orbital plane of our solar system.
Okay, thanks, Russ. I mean, we've seen some absolutely spectacular comets at SLU over the last 17 years. We're going to share some of them a little bit later. But hey, listen, Russ, we need to move on. Just before we hop over to Mike, and we're going to look at some of his images and work out how to tell viewers how to see it. Are you going to give us a quick update on what's happening in the world of SLU education?
Yes, yes. There are a ton of summer camps going on right now that are using SLU for their summer camps. We've got a space camp at Pierce College in Washington. We've got the Thomas Planetarium in Anchorage, Alaska. They've got a space camp that's using SLU as the basis for their camp. We've also got Astronomy in Action, which is in Toronto. They're doing a space camp, and we've got astronomy in India, Spaceport, India. So we're global. We've got a lot of things going on. We're looking toward the fall as well for our programs. We've got some universities, University of New Hampshire, University of Maine, who are using SLU in the fall, and a ton of elementary, middle, and high schools as well. So a lot of fun stuff going on. Reach out to me if you're interested. My name's Russ at SLU.com. I mean, there's great stuff going on, and we'd love to get you on board doing experiential astronomy education, which is unique. SLU is unique. We're experiential. They can experience it. They can take their own pictures. It's amazing. We just finished up space camp. It was a ton of fun here at SLU, and just good stuff going on. So Paul, thanks for having me on today.
Excellent. Well, thank you very much for that explanation of long and short period comets, and of course the update. So don't forget, if anybody out there knows any children, basically, or college students who might be interested in space and technology and astronomy and want to use enormous telescopes up on the top of a mountain when it's not cloudy, of course, which is very rare, especially at this time of year. It's cloudy because we did it here. You just need to email russ@slu.com and he will sort you out. So if you know any child, if you know any adults who know any children, then you need to get them in touch with Russ. So thank you very much, Russ.
One last, yes. It's more fun if we explore space together. So
it is.
Classrooms, groups, astronomy clubs, we're having a good time. And so, join us. We'd love to have you.
Exactly. And that's the same for the normal membership in SLU as well. I mean, we often talk about our worldwide community. Anybody who's not watching or not part of our Zoom meeting will not see that we've got, a whole bundle of SLU members here with us tonight. And we do astronomy every single night together like this, collectively around the live telescopes in the Canary Islands. Let's take a quick look at the Canary Islands, just in case it hasn't, the comet has disappeared now from view. Yes.
Oh, a question just before we get off topic. We do, I was looking at we have a chat feature in case you're not familiar with this in Zoom. And there's a couple of questions. One is from, the first one here from a couple of youngsters. One is from Aiden, age 8, asks, who discovered Neowise?
Neowise, right? Okay, so Neowise is. Shall I take this one, Mike?
Absolutely. I was looking at you, Russ, or you. Absolutely, yes.
Yeah. Okay.
Please.
So WISE is was a space telescope that was launched in 2009, and the WISE. Astronomers always come up with these. They like to string these words together and come up with these nice little names. WISE stands for Wide Field Infrared Survey Explorer Space Telescope.
There you go.
All right. December 2009 it launched, but it didn't last very long. This is an extraordinary telescope, and it cost a huge amount of money. I mean, big wedge this cost, Aiden. And they had to put it into hibernation in 2011. So it only really lasted for a couple of years because it ran out of coolant. They used the same kind of cameras, these really advanced scientific CCD cameras on telescopes like that, the same ones that are connected to SLU's telescopes in the Canary Islands that members use every night. Well, it ran out of coolant, which meant that it wasn't very good at its job. But then some bright spark, and I'll tell you, there are some bright sparks who work with space telescopes. He came up with this idea. Hold on a sec. It might not be very good to use for that, but we could use it even without this coolant to try and search for asteroids and comets, which together are called near-Earth objects. So in 2013, they basically switched it on. I like to think that there's a kind of big lever somewhere in the control room, and they just kind of pulled it down, and the space telescope Neowise, Wise, kind of sparked into shape. And anyway, Neo means new. They renamed the entire mission Neowise, and that is who discovered this particular comet on the 27th of March, 2020. So this is a really recent discovery, and actually it was already quite close to Earth and quite bright. But because it was on this inclined orbit that Russ was saying, a lot of the big surveys, the professional surveys that image huge swathes of the sky, they tend to stay, you know, in the ecliptic plane, the plane where the planets and asteroids are, to make their discoveries. But this one was, you know, way up high, and they discovered it, and that's the end of the story, basically. So yeah, any other questions, Mike?
There's one more from Jesse, who's age 7, asks,
hey Jesse,
there's great questions, really insightful. Can a comet have 3 tails?
Ooh, well, you can answer that one, Mike. I can show you a picture a little bit later of one of the weirdest comet tails we've ever seen at SLU. So, Mike, 3 tails? Can you have 3 tails on a comet?
Here's the thing about, let's talk for a minute. You know, Russ got some great stuff going with science education and stuff. And I think this is one of the key things to learn about science, is that we never know anything for sure. And so what my answer to that question would be is, we don't think so. We haven't discovered that yet. We don't believe that there's a reason for that, but that doesn't mean that it can't happen. Okay. So there's never this absolute certainty. So it's a great question. I would encourage you to investigate that and see what you find and let us know. That'd be a Mike, great project.
I love the fact that you say, you know, in science, there's never any certainty. And, you know,
drives people nuts.
If there was one thing in astronomy that you can never, ever be certain about, it's comets. So we've got famous astronomer David H. Levy. Comet Shoemaker-Levy 9, if you remember, that's one of the ones that impacted Jupiter, just pummeled Jupiter. Jupiter kind of sucked it up. But he's got the best quote ever, I think the best astronomy quote ever. And he said, comets are like cats. They have tails and they do precisely what they want. Now, I know a lot of SLU members out there have got cats because they often appear in our Zoom meetings, walking across keyboards and stuff like that. But it's exactly that. And this is part of the problem, actually, that we've had over the last 10 years with comets, as far as the media has been concerned, because comets have been discovered that were going to pass quite close to the sun. And suddenly the media say, this is going to be a great comet. It's going to be the best comet in 100 years. And then before you know it, it fizzles and sizzles, gets too close to the sun, burns up, and we don't see anything more of it. So many comets, they do this perihelion, this close approach to the sun. And when they get close, they can break up because of the sun's gravity, especially when they're slingshotting on that parabolic orbit. They break apart, put on an enormous show, sometimes hidden behind the sun from our perspective, but then they don't actually reappear from the other side of the sun. I mean, Mike, we've had quite a few examples of this, haven't we, over the last, 5-6 years? I mean, Comet Ison probably was the big one.
Oh,
yeah,
right.
Richard saying Comet Ison, you know, remember how big that was in the media. And the problem was that was going on for 12 months. The media were pumping out, this comet's going to be so brilliant by the end of the year. And we were waiting. And it kind of looked okay-ish, but then it didn't, it fizzled. It absolutely fizzled. But hey, listen, I want to get back to this member's image. This is once again from Bernd, who posted this today. Bernd Luchtenhoner, who is our #1 comet hunter on Sleuth. And I wanted to show you this. This is something that he's taken from his attic, would you believe? And we can see here very clearly the two tails that Mike was telling us about earlier. So all of the white, you can always tell the dust tail, because the dust tail in a comet is always white. And as Mike was explaining, the ion tail is usually a shade of blue, possibly green. And don't forget what Mike was telling us earlier. We know exactly where the sun is when we look at the ion tail, because the ion tail points directly to the sun. So the sun in this has just probably set about an hour before, 2 hours before Bernd took this image. But Mike, I wanted to talk to you about, because we were talking about this earlier, the scale of this thing is enormous. And we're going to see it in some of your images a little bit later. Now, people ask, how long is Comet Neowise's tail?
Yes.
Well, it kind of depends on how you're viewing it, because if you view, when Bernd took this image with his sensitive camera, he was looking at it with his naked eye. His naked eye is not as sensitive as his camera, so he would not have seen anything of this detail. He wouldn't have seen certainly the length of the tail. But what we've seen, and it looks, you know, roughly the same as some of the other images that I've seen of Comet Neowise, and I know you yourself have estimated, you know, in an average exposure at the moment, you can see about 15 or 20 degrees in the sky, the tail arching across. So Tim's holding both his hands out as a kind of measurement of the sky. Mike, how does that translate into miles or kilometers that we might be able to comprehend a little bit better?
Yeah, it's a great question, Paul. Actually, I was thinking about what you were just saying and letting my mind wander and so forth. And when you think about it, I'm not going to, this isn't a digression, but if you think about an annual meteor shower, like the Perseid meteor shower.
I was thinking exactly the same thing. I know what you're going to say. I love it. Go.
All right. Well, so, I mean, when you think about it, comet, as it's spewing out this material in space, the stuff really doesn't go anywhere. And this comet is going around and around and around. So if you think about the actual length of its tail, it's probably however many billions of miles the tail
it's
orbit is. So
it's leaving that material
so
all around its orbit.
Something to think about with that. But in terms of, so if I could share my screen for just a second.
Yes. Yeah, carry on.
I'm going to try a couple of things. And to answer your question about, I want to continue. So I want to show, the first thing I want to show is, because I really want to come to this issue of how people can find it and then use this. This is from Sky and Telescope magazine. And this, you can Google this. I want to make it clear, this is a Sky and Telescope magazine graphic. It's a great graphic. It's for the next week or so. And it shows roughly where the comet location would be relative to a very familiar constellation to us in the Northern Hemisphere, the Plough, or the Big Dipper, the asterism inside the constellation Ursa Major. And so with this graphic in mind, hold that in your mind. And now what I'd like to do is to share another image that was just from a few days ago. And that's this one right here. And sure enough, you can see this was one that was taken as a single exposure.
Ooh, that's lovely.
You can see, I just sort of outlined the stars of the constellation. You can see the Big Dipper. I outlined that in yellow, very prominent. And it's really well positioned, and the legs coming down. You can see the feet, and then sure enough, you can see the comet there. It's right there at the head of Ursa Major. And as we'll go back to this graphic now, so we can see what that looks like. And with that perspective, you can see now where so that was, I believe it was on either the 15th or this, I don't even know what day it is, 18th today. So it was either the 15th or the 16th. I think it was maybe the 15th, might have been the 16th, but it's one of these 2 days. So now the comet's moving. Look how quickly it moves. This is what Russ was saying, is this thing is just scorching along. And so if any of you watching want to go out and find this comet, all you have to do is find the Big Dipper and look underneath it after it gets really dark. I don't know if we have time to talk about the different phases of twilight, but let's talk about your question.
I don't think we can go into the different phases of twilight, but if anybody does want to see it, tonight, it's unfortunately we were going to see it in the live telescope views. It is incredibly close to a magnitude 3 star in the constellation called Talitha. And that makes it incredibly easy, to find, because you can trace that constellation diagram and know exactly where it is. Oh, time lapse. Very nice, Mike. So when did you take this?
So this was, I think that one of the nights before that, and there's a little twinkle of aurora borealis in there, and you can really see the ion tail here in the morning. I don't know if you can see that faint blue line, some ground fog that comes in very mysteriously. And then it starts to turn into dawn. So let's watch that one again. But I wanted to show this because it illustrates the point that Paul was making, is that we're looking essentially due north right here. And there's the aurora, and you can see the faint blue ion tail off the left, and it's pointing at the sun. So right now the sun is right below the horizon as far as it's going to go. And then it starts swinging around to the east, which is to our right. And you can see that that dust, the 2 different dust tails coming off the comet. So let's now go back to one more image, and we can do a little bit of math, because we love math. And
we need to know how long this tail.
We need to know how long the tail is.
That's
so
pretty.
So this is not anywhere near up to the one that we just saw from I think it was Burned, was it?
Yes.
Yeah. So marvelous job, and I'm a little reluctant to share it. But so here's the thing: I do know this image was taken with a particular lens. And for this particular lens, all lenses have a characteristic field of view measured in degrees. It's an angle. So it's like if you think about a telephoto lens is a very narrow field of view and a wide. So this particular field of view for this lens is 15 degrees on the wide side of the image. So from the left to the right is 15 degrees. Now, let me ask, I almost feel like doing a poll. How many degrees long do you think this tail is if it's a 15 degree from the left to the right? What do you guys think?
My estimate would be about 12.
So let's say 12 degrees. Okay. So now this is where we get to use.
Oh no! If you're doing math, then I think my estimate would be 12.395, just to make math more difficult. Okay. Mike, yeah.
You know what? I can do that because I happen to have a 12.395. I have a spreadsheet because that's what we do.
He's always ready, this man. That's why he's a doctor, you see.
So here's the beautiful thing. So it's for and this is especially for those students who are learning math, trigonometry and this sort of thing. And this is the sort of practice, like, why do we have to learn about the tangent of angles? And so you can measure the length, you can estimate, you can, impress your friends with how long the tail is in millions of miles. So when this image was taken, this comet was 71 million miles away from us. That's a pretty big distance. I mean, I don't even know I can't wrap my head around that, but that's a number. I'm going to use miles. It's almost like using liters to talk about pints of beer. But anyway, we have 71 million miles away. And then if we estimate 12.395 degrees for the comet tail, that gives us the length of this tail of 16 million miles.
Whoa!
What we're looking at here is a 16 million mile long comet tail.
And that's just what we can see.
And that's just what we can
captured in this image. If you'd taken longer exposures, then we would have seen more tail. And as you say, this dust debris that it's leaving behind goes on for its entire orbit. It does disperse over the years, but that's absolutely astonishing. And some comet tails have been measured up to 100 million miles when I was doing a little check today. And I mean, it's just a gargantuan scale. And I kind of love these big numbers because they just show the true scale of this. So you're saying, did you say 16 million, Mike?
16 million. So 16 million miles.
16 million miles long. But what we've been saying is the comet's coma, its head that we can see, that's maybe 10,000 miles across. But the comet's nucleus, the solid bit right in the middle of it, is probably only about 3 miles across. But it's responsible for this enormous tail. But they're tiny, tiny little bits of dust and gas. But all of that lovely reflected sunlight gives us these astonishing views. So Mike, if you finished screen share, I'm going to do a screen share so that we can.
I have.
Okay, because I just wanted to show viewers what it was like, and this is still pertinent for what we're going to see during the week. So thumbs up if you can see my sky chart at the moment. This is not from Sky and Telescope. This is some Monsieur's Cox astro diagrams. Copies are available. So this is roughly, this is all set up, all right, for tonight. So it was at tonight's date, and it's from the Canary Islands because the view changes depending on how far north and south you are, really. And you can't see this if you're much further south than the Canary Islands. You certainly can't see it from the southern hemisphere. But what I wanted to show here is, although we were hoping to bring you those live telescope views tonight, this is not a comet which is actually very well suited to a telescope view because it's so vast. And this little series of charts, I'm trying to illustrate this. So this is kind of what you'd see if you looked northwest tonight. But let's zoom in a bit then. If you've got a pair of binoculars, and I would certainly recommend using a pair of binoculars if you do want to view this visually, you can see that's the kind of field of view, about 50 degrees across. So that immediately, you know, what we were saying before, 50 degrees across, it's going to be about a third of the width of this field of view. That's what you see. But you're not going to see the kind of detail, even in a pair of binoculars, as Mike's photo. But if we zoom in even more, here we can see the telescope field of view. Now, actually, let me just hop back a sec. You see that little rectangle? So there's binocular field of view. You see this blue rectangle? That is the field of view. That's the amount of sky that the telescope, SLU's telescope, with the largest field of view can see. That's the amount of sky that it can see. So let's take a close look at that. And here we can see, there's one more. Here we can see it. So there's Canary 3 deep sky. That was a telescope that we were going to see tonight. That is only about a degree from top to bottom. So we were only going to see about a 15th of the comet. We were going to see the comet's coma down in the bottom. We were going to see that bright star Talitha, and then we were going to see its tail stretching up across the images. Now, I say we were going to see that. This is exactly what we're going to see on all of the coming nights in the telescope views. So we've still got to do some fairly clever stuff, but you can see that actually this particular comet is better suited to a pair of binoculars and going out to see it with your own naked eye. But I also wanted to then show you some of the comets that SLU members have captured over the years that do suit telescope views. So this one here, this is back in 2004. This is, you can see, look at that distinctive ion tail. And this is one of the lovely, lovely things. So you remember that quote about, you know, comets, you know, being like cats, they do exactly what they want, have tails and have a tail and do exactly what they want. Every single one of these is like a person's fingerprint. They are so unique. And all of the ones that I'm going to show you here were suited to telescope views, SLU's telescope views, because they were basically a lot smaller. So there's one from 2004. I'm going to skip through this quite quickly just to show you the variety. So here's another smaller one. And you can see we've even had to zoom in on this, you know, to see the comet, but we can start seeing some great colors on some of these comets as well. This one was even fainter. Now, don't forget, this is from Bernd Luchtenhoner. I'm sorry, it's a little bit small on the screen, but he has recovered several comets as well. which means he's the first person to capture or spot one of these periodic comets that Russ was talking about earlier, the ones that come around, you know, under 200 years, and he's been able to be the first person ever to spot it as it comes back into the solar system. But look at these tails, look how different they are. In fact, I could, I guess, do that. That's a little bit better, isn't it? Makes it a bit better. This was one of my favorites. I think this was Comet Jacques. And in fact, what we can see there is, I can't remember actually if that is Jacques, but we witnessed live over the course of the night. Mike, you were talking about the solar wind and solar radiation. Sometimes if you get a burst of that, there's energy from the sun, it can actually snap a comet's tail clean in two. And we get one of these tail disconnect events. And that's exactly what we saw here. It suddenly, just all of this material just basically snapped. And it was remarkable to watch it because we saw it all in one night. Tiny little one here, Euclidon, and you can see just how unique. Oh, this is the one that I was talking about earlier. Look at this, Mike. This has got two tails, not three, but it's got two. But what on earth is going on here? We've got one tail going in one direction and the other tail going in the other. And this is called an anti-tail, isn't it?
Exactly.
So what causes that?
Well, it really has to do with, if you think about, you know, so the tail on the lower, the horizontal tail, is the ion tail that's pointing directly away from the sun. And the other one, if you think about like someone who's got a torch and they're running with a strong wind and the wind is blowing in the opposite direction, then they're running in a certain direction. So you think that the trail would be going behind them. But in fact, if the wind is blowing farther from behind them to frontwards, then the trail would actually extend out towards them. So you have these two different directions between the dust trail and the ion trail. And this is one of my favorite sayings, is when you have a comet that is chasing its own tail because it's actually moving in the direction of the trail. So you think that it just kind of like blazes, like when you think of a meteor that comes into the atmosphere, it just leaves behind a trail that's very distinctly following its direction. But comets just aren't like that.
And this is all a matter of perspective. It's when the Earth and the comet are on the same kind of plane. And the lovely thing about an anti-tail is it is this perspective that we see it at. And that means that it only lasts for a few days. You don't normally see that perspective. And then very quickly, the tails appear to, you know, be more aligned, as we've seen. But we've still got some beautiful examples here, I think, if I can.
Paul, on that note, there is a question from from Carol Botha, who's asking, I've read that there is a phenomenon, the anti-tail, which seems to go towards the sun. Is this, however, an optical illusion?
Yeah, I mean, we know that certainly an ion tail is never going to go towards the sun, but you do get these strange optical illusions when the Earth, it's basically that diagram that I showed earlier, you know, that inclined orbit. We see these strange perspectives when the comet is on the same plane as the Earth. Because we're suddenly kind of almost seeing a cross section. So that's why you can see, you know, one of the tails appearing to be in front of the comet. But the ion tail is always going to be pointing away from the sun. So I'm just going to, I need to get, we need to finish off because I wanted to just get to a couple of my favorites here. Let's just have a quick look at these actually. So this is Comet Lovejoy Q2 Lovejoy. We've had the discoverer, Mr. Lovejoy, on a few shows over the years. He used to work in one of the Australian observatories, and that was absolutely beautiful. I love this one. I love this image. This is from member Jean-Paul Mertens, and what he's done here, the three rectangles, this comet was too big to view in a single telescope view, you know, those fields of view that we looked at before. So what he's done what Cameron has set up for us all to have a look at tomorrow night. So tomorrow, the telescope's open. He's got his first image, which is on the comet's head, the coma, and then he's taken a series of images up. And I know that Cameron's going to be spending probably about 3 solid days with no sleep, joining all of those together to produce an absolutely spectacular image that he will share, hopefully, in the Astronomers Anonymous Club at SLU. But that's exactly what Jean-Paul did here. So he's joined together these 3 images of different fields to capture more of the tail. But then the moon wasn't really there. But what he's done is he's given us this perspective of how big the comet is, its apparent size, how big it looks in the sky in comparison to how the moon looks. And I love those kind of comparisons because it puts a little perspective on. I don't know if you can see, but there's 3 lines down here. He's actually, well, art astronomers, people who love to produce beautiful images, would be crying if they saw this, but I actually think this is quite interesting. We can see 3 lines down here. That's a satellite, an artificial satellite, whizzing through the field of view as the long exposure image was taken. But yeah, a lot of images are spoiled like that. Let's just have a look, because this is, we're going to finish on this one, folks, because this is from David Malik, possibly my favorite comet that we've ever seen at SLU. This is Q2 Lovejoy as well. So David saying here, he took this 29th of January 2015. We watched this comet over weeks and I think a few months, and you can see just how disturbed its tail is. And all of that is because of this thing that Mike and Russ have been talking about. All of those volatiles in the comet's nucleus get heated and they get excited by the sun's energy and they sublime. It's one of these lovely processes where it doesn't turn to a liquid, they turn straight to a gas, and that's called sublimation. So you get these ices that turn straight into gas. And when that happens, that generates quite a lot of energy. And we know, Mike's been telling us, it's a dirty snowball. It's full of dust as well as all of that ice. And when that reasonably explosive process of sublimation occurs, it pushes off loads of dust at the same time. And most of these, or a lot of the waves that we see and a lot of the structure we see in the tail are caused by the outgassing happening at different times and rates. Some of it is also caused by the solar wind, isn't it, Mike, as well? You know, so we can actually see, you know, stronger blasts of the solar wind in comets' tails. Is that right?
It's something worth appreciating, that these things are nature is very irregular. And, you know, when you think about the precision of the orbits of the planets and how we can line things up, that's true. But some things like this is like, you know, you're taking a stroll in the woods and you find a rock. I mean, every rock is slightly different. And if you look closely at the rock, every rock has little different details in there. And it's these differences in the details and the age of the rock and everything that accounts for these differences, these magnificent, just like you say, it's a fingerprint of for each comet. So it's really neat to see that, because it almost gives you this sort of 3-dimensional feeling to it.
That's not so neat, is it? Sluvians, as SLU members are now officially called. This is not a view we want to see. So we're all going to basically get an early night. If you've got some DIY to do, if the family haven't seen you for a number of days or hours, then, you know, you can turn around and say, actually, unfortunately, it might be summer in the Canary Islands, but it's a bit cloudy, so I'm all yours for the evening or something. Russ, you got anything to jump in on?
Hey, yeah, Paul, there was a question asked in the chat. I just want to talk about it for a moment.
Oh, yes.
The question was asked that, you know, a little while earlier, we mentioned the relation between a meteor shower and this debris left behind by a comet.
Yes.
So the question was asked, are we going to get a meteor shower from the Neowise comet? And I don't think that we will pass through that debris. I don't think its orbit is such that the Earth will pass through it. Do you guys have any perspective on that, or a different?
I will pull up the orbit diagram so that, because it'll be easier to explain, and this oblique one is the best one. Now, what we can see here is the blue line here is the comet's orbit. And we can see that it's below the plane of the solar system when it was approaching the sun, then it passes through, and it passed through that. Look, around, you see where it crosses over there, where these vertical lines, where it was below the plane, and then it passes above. That happens roughly where Mercury's orbit is. So the dust trail that it's leaving behind, only the planet Mercury is likely to be near that. And it would have to be exactly through it for it to be a decent meteor shower. So what we land up with, we've got the Perseus meteor shower, I think at the next month. And all meteor showers that we have, we see sporadic meteors all the time. So these are meteors that just go in any direction in the sky. We can see them every night. But a meteor shower is when Earth passes through the debris. Imagine a tunnel. Imagine this stream of debris that a comet has left behind. And it's when that comet, and this is what I always start, you know, my brain, I know Mike's brain works in the same way. Hold on a sec. Earth is passing through the same bit of space that that comet did. Well, that didn't work out too well for the dinosaurs because they happened to be in the same bit of space at the same time. But hopefully that won't, you know, happen again. But so it's that remarkable coincidence that the comet passes through the space where Earth happens to orbit. And when Earth passes through that debris field, and we're talking about minuscule specks of dust, you know, I mean, even the largest ones are kind of no greater than a raisin or something like that, but most are kind of grain sand. Even to produce quite a bright meteor, it's a particle the size of a grain of sand that's come off the meteor, and we pass through that, and that's why we see them, you know, in a storm, a meteor shower or a meteor storm. So unfortunately not, because what we can, so for this comet, we're just going to be so far away. We can see how far away, you know, that when Comet Neowise passes Earth's orbit, it's going to be a long way above it. So not this one, I'm afraid.
Yeah.
So, any other questions?
We will do a celebration though for the Perseids. I think we're going to do a show, right? And that is
we are.
And yeah, that's a Swift-Tuttle. Isn't that the Swift-Tuttle comet tail that we're passing through there for Perseids?
Yes, it is. And there's, you know, all of the, let's have a quick look actually, make sure that we've got the right day, because I only added this to our schedule the other day. So so you can go to the shows page. Well, oh, Mike's on next week, another Nightscape if he's still awake, that is. Then we've got, oh, this is a good show. So this is July 23rd. We're going to start people off. We got this really young moon that we're going to look at, tiny thin crescent moon, and it's a great time to start the lunar phase quest if you haven't done that one already. Formation of the moon, this is a big one. We got some of the members in the house tonight, Daz, Carol, and Divya, and a few other people. Oh, Cameron's doing it as well. They're doing the first SLU Ambassador Star Party. So they're running the whole thing. So Russ, Mike, myself, we're going to be sitting back, you know, enjoying ourselves that evening with a nice cup of tea, being entertained by you lot. So that'll be quite good. Formation of the moon, there we go. Perseid meteor shower, August 11th. So the night of August 11th, that is the peak. Now, unlike last year, this is not going to be disturbed too badly by the full moon. But that should be pretty good. We've got some nice live feeds. And if you remember the last meteor shower we did, I set up a special little feed here, and they were coming thick and fast. You know, I mean, and the Perseus is a good shower. It's not one of the giant ones, but it's a good shower. So we should see some really cool meteors. And every single one of them you see, you know, is a little fleck of dust or granule from one of these amazing objects, these comets that we've been looking at tonight. So any other questions? No, I can't believe it.
Great comments. I mean, my goodness.
Have we told everybody everything that they ever wanted to know about comets? Have we exhausted the collective knowledge?
We've got one from Cameron. He says, are comets' orbits altered when they pass near Jupiter?
Yeah, they are. So are asteroids as well. So we've got the near Earth asteroid A-Team club of SLU members who monitor and track near-Earth objects. So near-Earth objects made up of near-Earth asteroids and comets. So we've already seen some of the superb stuff that Bernd Lütgenhoner does, monitoring comets. But what they do is they
winter, but we're fingers crossed. It's a pretty bright comet, so we're fingers crossed to the end of July, hopefully, so our southern hemisphere friends can enjoy a peek of it.
Yeah. And it's already been, so it already went through perihelion on the 3rd of July. So that's its closest approach to the sun. And if you think about that diagram that we showed, you know, that's where it's really, you know, under a lot of strain from the sun's gravity. If it survived that, then it's probably a fairly solid chunk.
Right.
But what we know is the further away it gets from the sun, the less of the sun's energy is sublimating all of those volatile ices that make up its nucleus. So it does start to fade the further away from the sun it gets. But Mike mentioned something really, really interesting there. It's about cometary breakups, and we do see that. But there's something else as well. When a comet doesn't really break up into multiple pieces, which we've seen this year with a couple of comets, but what they can do is they can have a cometary outburst. And this is where the sun's energy is not changing in the amount of energy that's hitting it. But what can happen is the surface can get disturbed. Imagine a huge landslip on the comet, which exposes loads of fresh volatile ice that then gets pummeled with all of those ultraviolet rays and the sun's radiation. And woof, off it goes into a cometary outburst. And this goes back to David Levy's, you know, quote, that comets are like cats. They have tails and they do whatever they want. You can never, ever be certain about what a comet is going to do next. And that's why, you know, you really need to be tracking this every single night, and all comets that we can see in SLU's telescopes, because certainly, check out, if you hop over to the clubs, I'm a member of quite a few clubs, so it might take quite a long time to load. But if you hop over to the Comet Trackers Club, go and join that. And they monitor comets over a long period of time. And you'll see from night to night, they change. And so I've lost count, actually, of how many times SLU members have been the people who have first spotted a comet outburst, or maybe break apart, or the first signs of it breaking apart, or that comet tail disconnect and stuff like that. So that you've got to, they are one of those options that you just need to observe every single night. Always set up a few cometary missions. And as you saw, you know, if you go into the schedule, if you don't know how to set one up, then you can hop into the telescope schedule and you can robo-snap somebody else's comet mission. So how are we doing? How are we doing, folks? In fact, I think, oh, look, there's some asteroid missions there. Oh, Juno. Sorry, I was getting distracted with all the interesting, oh, look at, what are they looking at tonight or tomorrow night? Let's have a look at tomorrow night, because we're closed tonight because that horrible weather. So we've got all comet. Oh, we've got the Canary 2 telescope. Stephen and Man is all. Cameron, you've got a lot of missions for Comet Neowise. Anybody would think that you're a bit obsessed with Comet Neowise, Cameron. I think you've got an issue here. We'll get you some help. Looking forward to seeing your missions. But anyway, don't forget, you can watch Cameron's missions live, or you can do what I'm doing here. I'm robo-snapping those, so I'm going to grab all of the images from your missions if I can't watch it live tomorrow night, which I will be doing. So anyway, last opportunity for any questions.
Do you remember Comet Holmes back in 2007?
I do. That was a good. What was that? The one that had that kind of really stubby coma on it?
It was just it was normally it's about a 14 magnitude comet, and for some reason it just sort of blew. My wife called it the fried egg comet because different levels.
Exactly. You see these extraordinary shapes, and yeah. Every single one of them is so different. But I'd like another Q2. That one was, I think, one of my favorites, and the color as much as anything else. So thanks, Richard, for that reminder. Anybody else? Otherwise, we will call it an evening. We've been going for an hour and a half, and considering that the skies were looking pretty grim, and we didn't unfortunately have live telescope views tonight. I think we've done pretty well because everybody's stuck around. Thank you very much for that. We have got a clear forecast for tomorrow. I think the forecast, Andrew Dumbleton, let's have a quick chat with SLU's ops manager, operations manager, looks after the observatories. Andrew, you were working a lot last week because the Canary Islands were, well, you always work a lot, but you were working especially hard under frustrating circumstances, because this view that we're seeing here, Tenerife, the whole island had a power cut. Not there's one, but several of them, and you had to work with our partners there, the Institute of Astrophysics of the Canary Islands, I think for about 36 hours to get everything back online for us, didn't you?
That's right. It was, as they say, up and down like a yo-yo, and we'd just sort of recover the telescopes and the power would go out again. So we'd have to start all again. From scratch, but we've got most of them back. I think there's some PCs we still to recover. But,
and what's the forecast doing for us this week?
Well,
quite good, I think, isn't it?
It's good on paper as forecasts go. I mean, basically tonight was supposed to be clear in the forecast, and last night. And we've just had these incredible dust storms.
And that's what we can see here, isn't it? You know, it's not just the clouds, but it's that yellowness is actually the amount of dust in the air.
That's right. I mean, if we look at one of the graphs that we have access to, it just just before we came on air with the show, suddenly steeply went up again. So it looks very red and horrible.
So if we look at this panorama, so this is a 360-degree panorama. Andrew's been very fortunate. He's been at the observatory as well as me, and it's the most magical place on Earth because we're normally above the clouds. You're looking down on the cloud tops. But behind that enormous dome here, which is called the Optical Ground Station, which actually monitors space junk, would you believe? That's what they use this telescope for. But you can just see the silhouette of this kind of triangular silhouette back here. That's Pico del Teide. That's a huge volcanic cone on the edge of the volcano caldera. And what you can see in this view when you look at it during the day is if Pico del Teide disappears, then it means we've got some very thick dust. And if you remember right at the top of the show, I told you this observatory, our flagship observatory in the Canary Islands. Canary Islands is 300 miles off the west coast of Africa. What's on the west coast of Africa? The Sahara Desert. All right, and that's where this dust blows in, and it's called La Calima. There's a guide for it actually on the SLU website. If you want to learn more about that, you can find our guides in here. I think it should show up in a search, maybe. There we go, guide to La Calima. Isn't it great when you try something that you haven't rehearsed and it works? Look at this one. Oh, look, Andrew, look, you've got me digressed again. Look. Sahara Desert over here. I'm glad my geography was that good. Canary Islands over here. There's a little red dot. That's where the observatory is. And when we get these winds coming in, they blow this dust over. And we have to keep closed. We open up. You opened up last week, Andrew, under conditions where we would normally stay closed. But we wanted people to. I think Russ had some classes going on the online space camp, summer space camp. So we needed some live views. So we kept them online as long as possible. So that means you or I need to get over there before winter and get our cleaning rags out, doesn't it?
That's right. We'll get the J-cloths and the Brillo pads on the mirrors.
Oh no! Oh, that sent a shiver down my spine. Anyway, listen. Has anybody got any final questions? Otherwise, we will wrap up for the night. It's been I've had a great time, despite having no live views because of that horrible weather. But any last little things?
Just wanted to encourage people to join us more or less weekly for our Nightscape star parties. We do a lot of this type of stuff. We have a Nightscapes Club. You're all personally invited to join the Nightscapes Club on SLU if you haven't already. We have a great core of folks that we always have a great time. I don't normally do this, but I'll do a little plug. If you're interested, I do have a book on photographing and creating images like the ones we saw tonight. So
Quick, someone kick him out of the Zoom webinar. No commercials on Slew.
Yeah, I've been waiting for this moment, but
I did notice it earlier though, Mike, because I think we should support you in this, because when I was looking at your bookshelves at the beginning of the show, I thought that's an awful lot of copies of the same book, and then I thought, yeah, it's Mike's book. So come on, Slew members,
yeah, book 1 and book 2 over here. So if you're interested, but no, it's just a real great thing to see people from around the world as part of these star parties.
Exactly.
It's just such a heartwarming thing to have this.
And Mike, your advice, you've sucked people into using their cameras, which can be bought quite cheaply now. Especially, I always recommend, go for the secondhand market. If you're just starting off, you can pick up a secondhand DSLR camera for some nightscape astrophotography for, $100 on eBay. And the one that I always recommend is a lot of those Canons, which are great for astrophotography, they have that little flap up flash and they break. When they break, nobody wants to use them as a normal camera. So you can pick them up dirt cheap, because you certainly don't need the flash when you're doing astrophotography. In fact, I, like others, have had that annoyance when you have got an inbuilt flash and you do start your lovely nightscape exposure and the flash goes off.
Yeah, that sent a shiver up my spine for sure. But anyway, thanks for having us all on. It's been great, Paul.
That's great. And for the next Star Party, Mike, we want to see the number of books on the shelf severely diminished. All right. So,
absolutely.
Russ, got anything else before we leave?
Yeah, I'm just looking forward to your eBay store opening up with broken Canon cameras available. And I also I wanted to mention.
Go on.
We had I want to thank our planetarium partners who showed up tonight, and Dr. Knudsen from Southern Virginia University. I saw him in the audience here tonight. So this has been great to see a lot of familiar faces on the Zoom, and just a fun night. So can't wait to see the comment in the telescopes though. That'll be awesome.
Indeed, it will be. That's it then, folks. Thank you very much for joining this Slew Star Party to look at Comet Neowise. Couldn't see it, unfortunately, with the live telescope views tonight, but as we've kind of explained, Comet Neowise isn't best seen through a telescope. So if you can, follow Mike's brilliant instructions, look northwest at the moment, and you'll hopefully see it shortly after dusk. Pair of binoculars would be useful, wouldn't it, Mike?
Helps. Yes, for sure. But it's just half the experience is just being out there and fighting off the mosquitoes, and
No, it's best living in a place where there are no mosquitoes. Anyway, thank you very much for joining us all tonight, and thank you all the Slew members, and we've got some Slew ambassadors in the house as well tonight. Thank you very much, Don Matcholt. He's joined in tonight as well. Don, I'll be contacting you because we need to get you doing some Comet Star parties and teaching some of our Slew members how to
Prime time hours, if you will. I've been getting up very early in the morning, around 3:30 a.m. to view Cometa Neowise from my backyard. I've even been taking some pictures. A comet is a small, icy solar system body that, when it gets close to the sun, starts to melt and break up and outgas. So the comet itself will have the nucleus, the core of the comet, with coma, so the atmosphere of the comet, and if you're lucky, a long tail, and that's exactly what Cometa Neowise has. So the comet is now getting farther and farther away from the sun, so it will start to dim over time, but you never know how long it will actually last. So fingers crossed that Cometa Neowise continues to dazzle us in the sky for the next few weeks, and I really hope you get a chance to take a look at it. It's unlike anything else you've ever seen in the night sky. It's an indescribable sight, and you'll get chills the first time you see it when you realize what you're actually seeing. Someone that documented the feeling very well, and I watched his video, and his reaction was typical of what astronomy nerds, how they feel when they see a comet, and I was able to get him on the phone to talk to him about it. What was it like the first time you saw and photographed Cometa Neowise?
Oh man, it's so exciting, especially to have, I mean, I saw a comet when I was like